Hiya and welcome to Sampling of the Normal Distribution Lesson 5. Today we're going to be learning about z-scores. So again, we're looking at the normal distribution side of things. The goal of this lesson is to make sure you guys know how to describe a z-score and how it relates to a score in a set of scores. Also to use the z-score rule to calculate z-scores, and to use those z-scores to compare scores from other data sets. Coolio. So the first thing that we need to know how to do or know about is what a z-score even is. Okay, so a z-score is a number showing the position of a score in relation to the mean. And that definition is basically taken from the syllabus dot point up here. Okay. The next thing we need to think about is how we calculate z-scores. So we calculate z-scores actually using this formula. So that's what you need to write down here, and it's represented by a z for z-scores. It's x take away x bar over s. Okay, so let's talk through these. So this x is the score, the x bar is the sample mean, and the s is the standard deviation. Okay, so why don't we write those things down? So we've got, so we've got the score, we've got the mean or the average, and we've got the standard deviation. Okay, so it's really important that you know that rule because we're going to be using it a whole lot, and you kind of need it to do these problems. Awesome. All right, let's have a look at some questions together. So the first one says, in an IQ test, the mean IQ is 100, so that's important. And the standard deviation is 15. Dale's test results give an IQ of 130. Calculate this as a z-score. Okay, so straight away we're just going to put that into the formula. So what I know is that the mean is 100, okay, from this bit up here. I then know that the standard deviation is 15 from this bit of information in the question. And I know that the x value, or the score they're talking about, is Dale's test result of 130. So I'm going to do what they say here in these thinking points. I'm going to write down the z-score rule, which is the score minus the mean on the standard deviation. And I'm literally just going to do what it says. The Dale's score out minus the mean over the standard deviation. You're just going to type that in your calculator, and that gives you a z-score of 2. Okay. So just remember from last lesson we were learning about the normal distribution. So basically z-scores within 2 and minus 2, that lies between 95%, okay, of the normal distribution curve. So you just need to make sure you're thinking about those things and connecting them together. Alright, next one. A sample of professional basketball players gives the mean height as 192 centimeters, really tall, with a standard deviation of 12 centimeters. Dieter is 183 centimeters tall. Calculate his height as a z-score. So again, let's write out our rule. Remember, the more times you write out the rule, the less times you'll need to find it on that formula sheet of yours, which means you're going to save lots of time. Cool. So in this case, the mean height is this, so that's the mean. The standard deviation is 12, and this is your x value. Okay, so I'm subbing in 183 minus the mean height over the standard deviation of 12. And when I type that in my calculator, I get negative 0.75. And again, if you're thinking about the normal distribution curve, then z-scores between -1 and 1 correspond to 68% of scores under the normal distribution curve. So it's really important that you're thinking about that. Nice. Okay, let's have a look at number 3. So number 3 says to obtain the average number of hours of study done by students in her class per week, Kate surveys 20 students and obtains the results. Okay, so the first bit says calculate the mean and standard deviation. And then B says Robert does 16 hours of study each week. Express this as a z-score based on the above results. So what's happening now is we're kind of shifting gears to problem-solving type stuff, where you're actually asked to solve a problem in a context. Okay, so for part A, I would just be using my calculator, and that's what it says to do. So you can literally either just add them all up and divide by 20, or put them in the data mode. So you would have to go mode to 1, get in stat mode, then enter all the numbers in your list, press AC, and then shift 1 VAR or 4, and then choose the mean and the standard deviation. So the mean looks like X bar. So when I type that in my calculator, I got a mean of 14.25, so make sure you get that as well. And the standard deviation, which is sigma n on your calculator, is 4.75. Okay, and that's to 2 decimal places that I rounded. Again, you can calculate mean without stat mode, but you can't do standard deviation. Now the question actually asked me for 3 decimal places, so I'm going to put the 3 decimal places in there. Awesome. Okay, part B then asks you to work out the z-score, Robert's z-score. Okay, so it tells me that he does 16 hours of study each week. And I have just worked out, in this question, I've worked out the average and I've worked out the standard deviation. So I'm going to be using those in my solution. So I'm going to go, again, write out the rule. X minus X bar on S. So my score happens to be the 16 hours minus the mean that I worked out over the standard deviations to 3 decimal places. And once I've worked that out, that actually gives me an answer on my calculator of 0.368, and that's also to 3 decimal places. Okay, so that actually again corresponds with, if I think about the normal curve, then z-scores that lie between 1 and -1 account for 68% of the scores under a normal curve. Fantastic. Okay, so that's pretty much what you need to do to work out a z-score in a context or a routine problem. So you need to make sure you write down some summary points of what you need to know from this section. Any questions that have come up for you as you've been watching the video, and have a go at some questions from exercise 1105. Mark any out you're not sure how to do, mark it and show working how I've shown. Thanks heaps, guys.